At this time, we are going through the course related to Databricks Certified Associate Developer for Apache Spark. As part of this sectional module, we will primarily focus on sorting. When it comes to sorting, we typically sort the data in Dataframe. You need to be familiar about quite a few concepts related to sorting. If you focus and learn, the concepts related to sorting are quite easy. There might be quite a few questions with respect to sorting as part of the exam because it is very, very important to understand how to sort the data. If you explore this handful of APIs related to sorting, you should be able to answer all those questions with ease. Let's go to the details about sorting. I'll be covering quite a few examples so that you are completely under control with respect to sorting. Let's deep dive. As part of this sectional module, we are going to the details related to sorting data in the Spark data frame. As we have seen earlier, first let's make sure that we have a notebook which can be leveraged in other notebooks to create the data frame so that we explore relevant examples related to sorting. Just make sure you run the notebook, and if it is working fine, then you should be able to use it as part of the other notebooks to create the data frame quickly using this notebook. Then you should be able to explore the examples. As we have seen quite a few times earlier, I am not going to explain in detail, just validate and move forward with respect to examples related to sorting. As part of this lecture, let's get an overview of sorting a Spark data frame. First, let's run this cell. It will take care of creating a data frame by name users_df. Now, let's go to the sorting scenarios which we should be familiar with. These are the most common ones. There might be other scenarios as well. The first scenario is nothing but sorting a data frame using ascending order by a specific column. The second scenario is nothing but sorting a data frame using descending order by a specific column. Let's take an example and try to understand what they actually mean. If you want to sort the data in a data frame in ascending order by first name, the names are supposed to be sorted based upon the alphabetical order of them. In this case, Ashby should come first, then Corey, then Kurt, then Nicholas, then O'Reilly. When we actually sort the data in descending order by first name, then O'Reilly should come first, then Nicholas, then Kurt, then Corey, then Ashby. When we try to sort the data based on specific column, the specific column might have nulls. When we have nulls as part of that column, we should understand how to deal with scenarios where nulls should be displayed either at the beginning or at the bottom. You first need to observe the default behavior. If you have to change the placement of the null values, you have to explore appropriate APIs and then you have to take it further. So you should be familiar about how to deal with the nulls while sorting the data. You will see a few examples and it should be clear by the end of the sectional module. Also, when it comes to sorting a data frame, you might have to use multiple columns. If you have to sort the data in a data frame using multiple columns, it is called as composite sorting. You should be familiar about how to take care of composite sorting. When it comes to composite sorting, there can be 2 or more columns as part of the sorting logic. In most of the cases, you will be having 2 columns. In some extreme cases, you might have more than 2 as well. Let's take the example of sorting using 2 columns. When it comes to sorting data using 2 columns, then there can be 4 combinations. The 4 combinations are nothing but sort the data in ascending order by both the columns, or in descending order by both the columns, or in ascending order by first column and then descending order by second column, or in descending order by first column and then ascending order by second column. As part of the requirements, it should be clearly defined about how you should be sorting the data when it comes to composite sorting. You have to fulfill depending upon those requirements. Then comes prioritized sorting. Let's take an example and try to understand what it actually means. When you actually get into a website, sometimes you might have to fill in the country. Depending upon the country you are living in, that country name might come at the top. Rest of the countries might come at the bottom in ascending order by the country name, which means your host country is supposed to be come at top. For example, USA should come at top. Then rest of the countries should be in ascending order by the name of the country, which means you have to come up with custom logic where prioritized sorting has to be implemented. We'll see an example so that you understand what I'm talking about, but you need to keep in mind about prioritized sorting as well. From the certification perspective, prioritized sorting might not be that important, but as part of the projects, we might end up seeing prioritized sorting in some cases. That being said, as we have understood all different scenarios which are common with respect to sorting, now let's understand the APIs that are available on top of Spark data frames to perform the sorting. The 2 APIs are nothing but sort and order by. They are nothing but synonyms to each other. Let's look at the help on both. You see that it is actually giving the same output. With sort, it is saying sort. Even with order by, it is saying sort, which means sort and order by are nothing but synonyms. When it comes to sort or order by, they take actually 2 arguments. The first one is nothing but varying arguments where we can pass the column names. The second one is nothing but a set of keyword arguments which can be passed. you can actually see the details about the parameters. When it comes to calls, the calls can be of type string or list, or they can be even column type objects. When it comes to other parameters which can be passed as keyword arguments, it takes one argument which is nothing but ascending. The default is true. If you want to reverse the order, then you have to pass false to ascending, then the data will be sorted in descending order. Now let's go to the examples to understand the usage of sort or order by. When it comes to the first one, as part of sort, we are actually passing one argument, you can see here. However, we are actually referring to column name by saying dataframe name dot column name. This is nothing but the column name. This is of type column object. On top of column object, we have functions such as ASC, DESC. There are a few more which are relevant with respect to sorting. We'll actually go to those details as part of subsequent lectures in this section. In this case, we are using DESC, which means data is being sorted in reverse order by age or in descending order by age. You can also pass the column names as strings like this. So in this case, the sort is taking two arguments. The first argument is nothing but column name. The column name is passed as a string. As there won't be any functions such as DESC on top of string objects, we have to use keyword argument like this to actually sort the data in descending order by this column. Even this one will actually sort the data in descending order by age. Now you can also use order by in place of sort. This one and this one are same. We are only using order by in place of sort. As sort and order by are aliases, whatever examples you are seeing with sort here should work with order by also. Also, as part of pyspark.sql.functions, we have functions such as ASC, DESC, etc. Even we should be able to leverage those to actually sort the data. So in this case, it will actually sort the data in ascending order by age. We are actually passing ASC with argument age to sort. It will take care of sorting the data in ascending order by age. You can actually see here. Now let's take this example. This is an example for composite sorting. You can see that the order by function which is being used here is taking two arguments. Both are nothing but columns. When it comes to the first argument, it is being passed using DESC function which is available as part of pyspark.sql.functions. For that DESC, age is being passed, which means data will be sorted in descending order by age. Then data will be sorted in ascending order by name. Wherever you have duplicates with respect to age, the data related to that age will be sorted in ascending order by name. So here we are trying to sort the data in descending order by age, then in ascending order by name. Then comes the last example. You can see here. It actually takes two arguments. The first argument is list. In this case, it takes two arguments. Both the arguments are of type column. In this scenario, both the arguments are of type list. The first list contain the column names. The second list contain the way data is supposed to be sorted. So in this case, you can see that the first value is 0, which means descending order. The second value is 1, which means ascending order. So this will also take care of sorting the data in DF in descending order by age and then in ascending order by name. When it comes to this example and this example, both should return same results. Make sure you go through all the examples and be comfortable with the syntax. You might see few questions in the certification exam where they might give you the code snippet and ask you whether it is a valid syntax or not. You should be in a position to judge and answer the questions in correct way. As part of this lecture, let's go to the details about sorting Spark data frame in ascending order by a given column. First, let's run this cell. It will take care of creating a data frame by name users_df. You should be able to see the details with respect to data frame here. Also, you should be able to preview the data. Now, let's perform the first task so that we understand how to sort the data using a specific column. The first task is nothing but sort the user's data in ascending order by first name. Now, you should be able to specify the data frame name like this. Then you can actually say sort. You should be able to pass the column name as a string or as a column object. In this case, I'm actually passing a string. If you run this, it will actually take care of creating the data frame. You can see here, this data frame will contain sorted data by first name in ascending order. If you want to preview the data on this new data frame, either you can assign it to a new variable and then use show on top of that variable, or you can actually say show like this directly. You should be able to preview the output. Now you should be able to pass the column names as column objects. If you want to pass column names as column objects, then there are two ways. One, use the data frame name as a reference. Then you should be able to specify the column name in the data frame. You can see the output here. Also, you should be able to pass the column name in square brackets. When it comes to using square brackets, you have to pass the column name as a string to it. Let's see an example using that approach as well. Now we should be able to say users underscore df, then first underscore name. You see the output here. Also, you can actually import call, and you should be able to pass a column object by building column object by passing the call name to it. Let's see an example with that also. First, let me copy this. Let me add a cell here. Let me paste. Now let's replace this with call of first name. Before running it, let's make sure call is imported. For that, we should be able to say from pyspark.sql.functions import call. Now call is imported. Now you should be able to run this. You can see the output here. So these are different ways where you should be able to sort the data in Spark data frame in ascending order by first name. Now I have come up with solutions using sort. I have used different styles of sort. You can also replace sort with order by and run. All these will return exact same results because sort and order by are nothing but synonyms. Now let's perform another task. This time the task is nothing but to sort the user's data in ascending order by customer from. When it comes to customer from, it is of type date. You should be able to scroll up and review the data frame structure. You can see that first name is of type string. When it comes to customer from, it is of type date. Even with respect to date, you don't need to worry too much about tweaking anything. It should work in the same manner as it is working with strings. So here we should be able to use order by or sort, and we should be able to come up with the solution fairly quickly. Let's make sure that we copy this. In this case, we are going to use column object. Let's add a cell here. You just have to change the column name. In this case, column name is nothing but customer from. Now you should be able to run. You can see the output here. You can see that nulls are coming at the top. After nulls, you can see that data is in ascending order by customer from. The first record belongs to 2021 January 15th, followed by 2021 January 21st, followed by 2021 February 14th, which means data is in ascending order by customer from. That being said, you should be familiar about how to deal with the nulls. We will actually go through those details as part of one of the lectures in this section. For now, don't worry too much about nulls. When you try to sort the data in ascending order, if the column contains null values, the nulls will come at top. Now let's perform another task. In this case, we are supposed to sort the data in ascending order by number of enrolled courses. If you look at the columns, there is no column which actually talks about number of enrolled courses, but there is a column by name courses. When it comes to the data type of courses, it is nothing but list. This list doesn't contain anything. This list also doesn't contain anything. This list contains 2 elements. This list contains 2 elements. This one contains only 1. In this case, when we try to sort the data in ascending order by number of enrolled courses, we should get these 2 at the top, followed by this one. Once we got these 3 records, then we should be getting these 2. Let's go to the details about how to get the data in ascending order by number of enrolled courses. To get the data in ascending order by number of enrolled courses, first we need to get the number of enrolled courses by using this list. For that, we should be able to use a function called as size, which is available as part of pyspark.sql.functions. We should be able to use that function as part of sort or order by. Once we use size as part of sort or order by, we should be able to get the solution without any issue. Now let's copy this, paste here. Let's add one more cell. Let's import function called as size from pyspark.sql.functions. This will take care of importing the size. You can see that size is imported. Now we can replace call with size. We should be able to pass the call name as string to size. Now let's pass the column name. The column name is nothing but courses. So let me say courses here. Now let me run it. Now we should be able to see the results. You can see that it has sorted the data in ascending order by number of enrolled courses. If you want to display the number of enrolled courses, then you should be able to add additional column using with column like this, and you should be able to see the number of enrolled courses also. So let me say with column, then number of courses, then size of courses, then dot backward slash. Now if you run it, you can actually see the output. The last column contains the number of courses. Let's make sure that we drop some of the columns. We don't need all these columns. Instead of dropping, I'll be using select. So let me say select ID, then courses. These are good enough to actually review the results. Now let me run this. Now we can see the output. You can see that data is sorted in ascending order by number of courses. This is how you should be able to use even functions as part of sort or order by, and you should be able to get the results as per the requirements. That being said, we have gone through the details related to sorting Spark data frame in ascending order by a given column. Now it is time for us to explore to sort the data in descending order by a given column. We'll go through those details as part of the next lecture. As part of previous lecture, we have gone through details related to sorting Spark data frame in ascending order by a given column. In this lecture, let's go through the details related to sorting Spark data frame in descending order by a given column. First, let's run this. It will take care of creating a data frame by name users_df. You can see here. Now let's perform the task to understand how to sort the data in descending order by first name. Either you can pass the column name as a string type or column type. We'll actually see the examples using both the types. When it comes to passing first name as a string type, the logic will look like this. You can specify the data frame name and then you should be able to say sort. You should be able to pass the column name as a string. In this case, first name is passed as a string. If you want to pass column name as a string like this, then you have to use keyword argument ascending. You have to set it to false. Now you should be able to say show. This will actually result a new data frame in which data is sorted in descending order by first name. Now I'm invoking show on top of this new data frame. You can see that the data is sorted in descending order by first name. First you got Aurelie, then Nicholas, then Kurt, then Corey, then Ashby. The names are actually sorted in descending order. You can also pass the column name as column object. If you want to pass column name as column object, then either you can use the data frame then square brackets, then first name in single quotes. This is one way of referring the column names using data frame name. Now if you run it, you will see the same results. You can also say users_df.firstname. It will work without any issues with respect to Python as programming language. On top of this approach, when it comes to using column objects, you can also invoke a function that is available on top of column object. First, let me pick this. Let me actually create a new cell here. Then let me say C equal to, paste it, hit enter. Now C is of type column. Let me add a new cell here. You can actually say C, run it. You can see that it is of type column. If you say C dot and hit tab, you should be able to see bunch of functions. You can see you have ASC, you have DESC. You should be able to use this function to sort the data in descending order. ASC can be used to sort in ascending order. However, it is default and hence we don't typically use ASC. In this case, you should be able to leverage DESC and you should be able to sort the data in descending order. You can also see that there are few other functions. Some of them are relevant for sorting. Majority of them are not relevant for sorting. For example, DESC nulls first, DESC nulls last, ASC nulls first, ASC nulls last are related to sorting. Rest of the functions might not be relevant for sorting. That being said, we should be able to use DESC to actually sort the data in descending order by this column when column is passed using column object. Let me hit escape. Let me clean up these two cells. Now let me copy this. Let me paste here. Let me remove this. I should be able to say DESC like this and then I should be able to run. You can see that data is sorted in descending order as per the expectations. You can also import DESC function from pyspark.sql.functions and you should be able to use DESC function as well to sort the data in descending order by passing a column name in the form of string or column object. It will work as per the expectations. Let's see that also as an example here. Let me add a new cell here. First, we need to import DESC function from pyspark.sql.functions. Now DESC is imported. Now I can actually copy this, or I should be able to copy even this one. For DESC function, you should be able to pass the column name as a string or column object. In this case, I would like to demonstrate using string. Let me clean this up. Now I can actually say DESC, then pass first name to it. In this case, first name is passed as string. Now you can see the output. So there are different styles using which we should be able to sort the data in descending order by a specific column. Now let's perform few more tasks to actually understand how to sort the data in descending order. In this case, I have messed up with the order. Let me move this to up so that all these code snippets are in appropriate order. Now let me go to the next task. In this, we have to sort the data in descending order by customer from. You can pick any of the approaches and you can take it further. Let me pick this one. In this case, to sort the data in descending order by customer from, I just have to replace the column name with customer from. Now data should be sorted in descending order by customer from. However, customer from have null values. If you look at the output here, the rows which have customer from as null came at the bottom. With respect to sorting data in ascending order, nulls came at the top. When we actually sort the data in descending order, nulls came at the bottom. We'll understand how to deal with nulls as part of the next lecture. For now, don't worry too much about nulls. However, make sure you review the data and confirm whether the records which contain customer from are actually sorted in descending order by customer from or not. You can see that the first record is the latest one, then 2021 January 21st, then 2021 January 15th. It is the oldest of all the three records. This is how you should be able to sort the data in descending order by customer from. Now let's perform another task. This time we would like to sort the data in descending order by number of enrolled courses. As we have seen earlier, there is no direct column which will actually give us the number of enrolled courses. However, using courses, we should be able to compute number of enrolled courses by using size function. Let's go to the details about sorting the data in descending order by number of enrolled courses, leveraging size functions, which is there as part of Pyspark.sql.functions. Now first let me copy this. Let me add a new cell here. Let me replace DESC with size. Now size is being imported. Let me pick this. Let me paste here. First, I would like to select only the fields which I am interested in. In this case, I am interested in ID. Then courses. Only those two fields I am interested in. I am not interested in anything else. I should be able to pass courses like this. On top of these two, I would like to see the number of enrolled courses also. I can leverage with column function. As part of the with column, I should be able to specify the alias first, which is nothing but number of courses. Then I have to use size and pass courses to it. Courses is of array type here. If a column is of array type, you should be able to get number of elements in the array type column using size function. Now we should be able to sort the data using number of courses here. Let me delete. Let me actually pass number of courses as a string. As I'm passing it as a string, I should be able to say ascending equal to false. Then I should be able to use show on top of it to preview the data. However, it is failing on courses, saying courses is not defined. In this case, courses is supposed to be passed as string or column object. Let me pass it as string. This time it should work. You can see the output here. First we got 1 and 3 where number of courses is 2. And then we got user ID 2 where number of courses is 1. Then we got 4 and 5 where number of courses is 0. As we have imported DESC function from Pyspark.sql.functions in the past in this notebook, we should be able to use it as well. So in this case, let me copy, paste here. Let me delete this. Let me use DESC here to sort the data in descending order. I can pass number of courses to it. It should work without any issues. You can also use the DESC function if you are able to convert this to column type. One of the ways to convert this to column type is by importing call function and use call function to pass call name to it to convert the string to column object. Once you get column object, you should be able to invoke DESC on top of it and you should be able to get the results as per the expectations. Let me actually demonstrate here. I have copied and pasted. Let me use call here. Once you have call, you should be able to use DESC. Now before running this, make sure call is imported. Call is part of Pyspark.sql.functions and hence I'm saying from Pyspark.sql.functions import call. Let's run this first. Then we should be able to run this. We can see the results as per the expectations. This is how we should be able to sort Spark data frame in descending order by a given column. Make sure you understand different styles of syntaxes which can be leveraged to actually come up with the desired outcome. Also, when it comes to the functions, we have both sort as well as order by. They are nothing but synonyms to each other. We should be able to leverage all the styles using either of the functions to actually sort the data in descending order by given column. As we are able to sort in both ascending order as well as descending order, in the next lecture, let's go to the details about how to deal with nulls if the column which we are trying to use to sort the data contain nulls in it. As part of previous two lectures, we have gone to the details related to sorting the data in a Spark data frame using specific column in both ascending as well as descending order. Now let's understand how to deal with nulls while sorting the data in Spark data frame using specific column. First, let's create the data frame. In this case, a data frame by name users_df is created. Now let's explore the functions that are relevant with respect to dealing with nulls. All these functions are available on top of column object. So first let's import call here. Call can actually return a column object if we pass call name as string. To import call, we can actually say from pyspark.sql.functions, then import call. Now call is imported. Now we can actually say call of customer from, assuming we'll be using customer from as it have null values to go to the details related to dealing with the nulls. Now we should be able to say cf equal to call of customer from. Now cf is created, cf is of type column. You should be able to validate by saying cf here. Once you run it, you should be able to see the type of it. It is nothing but of type column. Now I should be able to say cf dot and hit tab. You can actually review all the functions that are available. With respect to sorting, the most important functions are nothing but ASC, DESC. We have seen these two functions as part of the previous two lectures. On top of these two functions, even ASC nulls first, ASC nulls last, DESC nulls first, DESC nulls last are important. These functions will actually take care of placing the null values depending upon the requirements. Sometimes the requirements might say nulls should come on top. Some other time it might say nulls should come at the bottom. After reviewing the default behavior, we might have to use the appropriate function to actually place the nulls at the right place. Let's go to the details to understand how to come up with solutions using these functions by placing nulls at desired place depending upon the requirements. Before going through those details, let's delete this cell. Let me also delete this. Now you can see that I'm trying to sort the data in ascending order by customer from. First, let's run this piece of code where the data will be sorted in ascending order by customer from. We will see the default behavior with respect to null values by reviewing the output. Now I have ran it. If you review the output here, when it comes to the first two records, these two records contain null with respect to customer from. Then you can see that data is actually sorted in ascending order by the customer from, which means when you try to sort the data in ascending order by a column where the column contains null values, the rows with the null values come at the top. However, the requirements might say to actually place the rows with the null values at the bottom. You can see here, it says sort the data in ascending order by customer from with null values coming at the end. So in this case, we are trying to sort the data in ascending order and we want the null values at the bottom. To achieve that, we should be using ASC_nulls last like this. Now, if you run it, you can see that the null values are coming at the bottom. If you look at the first three records, the records are actually sorted in ascending order by customer_from. Now, you should be able to use call function as well to create a column type object, and once you create column type object like this, you should be able to use ASC_nulls_last like this. Using this approach also, we should be able to sort the data in ascending order by customer from where nulls comes at the end. Let's run these two cells and let's review the output. You can see that the rows with the null values with respect to customer from came at the end. The first three records are actually sorted in ascending order by customer from. Let's perform another task here. This time we would like to sort the data in descending order by customer from. Once the data is sorted in descending order by customer from, we need to understand the default behavior. Then depending upon the requirements, we have to use the appropriate function to place the nulls as per the requirements. In this case, if you run this, when it comes to sorting the data in descending order by specific column, the nulls will come at the bottom. You see here, the last two records contain nulls with respect to customer from. The first three records are actually sorted in descending order by customer from. However, when it comes to the requirements might say sort the data in ascending order by specific column with the null values coming at the beginning. If you have to get the rows with the null values at the beginning when you try to sort the data in descending order by specific column, then you have to use DESC nulls first. DESC nulls first will make sure that nulls come at the beginning. We have DESC nulls last. Implicitly, it will use DESC nulls last by default. That's why you are getting nulls at the end. In the similar manner, with respect to ASC also, we have ASC nulls first and ASC nulls last. The default behavior is ASC nulls first. If you want to do reverse, you should be able to use ASC nulls last and you can get the null values at the bottom. That being said, now you should be able to run this to get the nulls at the beginning, followed by those records where data is sorted in descending order by customer from. This is how you should be able to deal with the nulls while sorting Spark data frame. Make sure you are comfortable with all these 4 functions. They are nothing but ASC or ascending underscore nulls underscore first, ASC underscore nulls underscore last, DSC underscore nulls underscore first, DSC underscore nulls underscore last. All these functions are very important with respect to dealing with null values while sorting the data. As part of this lecture, let's go to the details related to composite sorting of a data frame. First, let's run this. It will take care of creating list of dicts. Once you have list of dicts, one of the ways to actually create Spark data frame is by using this approach. You need to import row, then you have to create a list of row objects. Once you have list of row objects, using this piece of code, you should be able to pass that list to spark.createDataFrame, and you should be able to create the data frame. In this case, once we run this, we should be able to create the data frame by name courses_df. We have seen this type of code earlier also, and hence I'm not actually going through too many details here. Let's focus on composite sorting using this data frame by name courses_df. You can actually review the column names as well as data types of this data frame by using this code. You can see that the data frame contain 6 columns. They are nothing but course ID, course name suitable for enrollment, stars, number of ratings. You can also review the data types of each of these columns. You can also preview the data by using this piece of code. You can see all the records here. As the data frame courses_df is ready, now let's go ahead and perform these 2 tasks to understand how to take care of composite sorting. The first task is nothing but sort courses in ascending order by suitable for and then in ascending order by enrollment. Let's review the columns suitable for and enrollment. Let me scroll up here. You can see that suitable for contain values such as beginner, intermediate, advanced, etc. Then comes enrollment. When it comes to enrollment, it have numbers. You can also check the data types here. When it comes to suitable for, it is of type string. When it comes to enrollment, it is of type big int. In this case, we are supposed to sort the data in ascending order by suitable for and then in ascending order by enrollment. Let's come up with the solution and review the output once we are able to come up with the solution. In this case, we are supposed to use data frame, which is nothing but courses_df. Then we should be able to leverage either sort or order by. You can choose whatever is your choice. In my case, I'll be using sort. We should be able to pass both the columns in multiple ways. One of the ways is by passing the column names as strings. So in this case, I can say suitable for, then enrollment. This will actually create a data frame where data will be sorted by suitable for and then by enrollment. If you want to preview the data of this data frame, you should be able to use show like this. Now you can see that data is sorted in ascending order by suitable for. Under advanced, you can also see that the enrollments are in ascending order, which means data is not only sorted in ascending order by suitable for, but also using enrollment. That being said, you can also pass the column names as column objects. There are multiple ways where you can actually pass column names as column objects. One of the ways is by using the data frame name and then dot, then column name, or data frame name, then as part of the square brackets, pass the column names as strings. You can use either of the approach. I'm using the latter approach here. Now this cell is updated. You can see that both the columns are passed as column objects. We should be able to run it and we should be able to get the results as per the expectations. That being said, we should be able to pass the columns as a list also. Let me actually copy this. Let me paste here. Now we should be able to enclose this as part of the square brackets. Column names are passed as a list of strings. You can actually see the output here. This is how we should be able to take care of sorting the data in ascending order by both the columns. Now let's perform the task related to sorting the data in ascending order by suitable for and then in descending order by number of ratings. Again, we should be able to use different approaches to solve this problem. Let's use this approach first, where both the columns are passed as column objects. As both the columns are being passed as column objects, we can use DESC function on top of the second column to sort the data in descending order by the second column after sorting the data in ascending order by first column. In this case, the second column is supposed to be number of ratings, and hence we should be able to copy the column name, paste here, then use DESC function. Now we should be able to run it and we can actually see the output. We can also use the DESC that is available as part of pyspark.sql.functions. For that, first we need to import, let's say from pyspark.sql.functions, then import DESC. Now DESE is imported from pyspark.sql.functions. We should be able to copy this. Let's paste here. We should be able to invoke DESE on top of courses underscore df, then number of ratings, not enrollment, as the task is related to ratings but not enrollment. This is the column which we are supposed to use. Let's paste here. Now let's run it. We should be able to see the output without any issues. When it comes to using DSC function, you should be able to pass the columns as strings also. So in this case, we should be able to come up with the logic using this approach as well. We just have to pass the column names as strings rather than column objects. Now suitable for is being passed as a string. Even with respect to number of ratings, we should be able to pass it as a string to DESC. Now if you run it, you should be able to see the results as per the expectations. You can see that data is sorted in ascending order by suitable for, followed by in descending order by number of ratings. You can also pass these columns as a list of strings. If you want to use a list of strings and customize the sorting order as per the requirement, the logic goes this way. We need to remove DESC from here. Once DESC is removed, we should be able to clean up these brackets also. Now we should be able to enclose both the column names in square brackets. Now we are passing the column names as a list. Now we should be able to say ascending equal to 1, 0, because the requirement is to sort the data in ascending order by suitable for, followed by descending order by number of ratings. Now you should be able to run it. You can review the output and confirm that data is sorted in ascending order by suitable for and then in descending order by number of ratings. That being said, we are saying 1 here because we want to sort the data in ascending order by the first column in this list, which is nothing but suitable for. We are saying 0 here because we would like to sort the data in descending order by second column in this list. So this is corresponding to this one. This is corresponding to this one. You need to understand this order. That being said, this is how you should be able to take care of composite sorting of a data frame. Make sure you understand the concept of composite sorting and also practice enough to come up with the solution based upon the requirements. As part of this lecture, let's go to the details related to prioritized sorting of a Spark data frame. When it comes to the certification exams, you might not get any scenarios related to prioritized sorting, but in general, as part of our projects, we might encounter requirements which involve prioritized sorting. We should be able to solve those problems with ease. That being said, first let's create the data frame by name courses underscore df. Now the data frame is created. You can actually preview the data as well. Now let's go to the details related to requirement associated with the prioritized sorting. In this case, we need to make sure data is sorted in custom order by level and then in numerically in descending order by number of ratings. So first we need to identify what is that custom logic based on which suitable for has to be ordered. Within each category under suitable for, data should be sorted in descending order by number of ratings. Now in this case, if you understand, when it comes to the courses might be beginner level, intermediate level, advanced level. The natural ordering of these levels are nothing but beginner, intermediate and advanced. But if you try to sort the data directly without having any custom logic, then you will get advanced first, followed by beginner, then intermediate. However, advanced should come at the end, beginner should come at the first. We need to come up with appropriate logic to sort the data based upon that custom logic where we see beginners at first, followed by intermediates, then advanced. Now let's come up with the solution. To actually come up with this solution, what I'll be doing is I'll be assigning a 0 for beginner, 1 for intermediate, 2 for advanced. If you assign those numbers while sorting the data, then it will ensure that beginners come at the top, followed by intermediate, followed by advanced. To convert beginner to 0, intermediate to 1 and advanced to 2, I'll be using when function, which is there as part of pyspark.sql.functions. Once we run this, we'll be importing when along with call. We should be able to review the help on when by saying help of when. You can see that when takes a condition followed by a value. If the condition is satisfied, whatever is the value specified here will be returned. On top of when, it also exposes a function called as otherwise. You can actually use otherwise and you can actually specify what should be returned if condition doesn't satisfy. So if you say when, then a condition comma value, then a dot otherwise a value, then If condition is satisfied, this will be returned. If condition is not satisfied, whatever is passed to otherwise on top of when will be returned. So using when and otherwise, we should be able to come up with the required logic to assign 0, 1 and 2 to beginner, intermediate and advanced respectively with respect to suitable for column as part of our data frame called as courses_df. So in this case, I'm actually coming up with the logic here. It is being assigned to course_level. Course_level will be of type column object. If you look at the logic with respect to this object, I'm using when. As part of when, 2 arguments are passed. You can see the 2 arguments here. The first argument is nothing but condition where the value in suitable for is being compared with beginner. If the value equal to beginner, then 0 will be assigned. If value in suitable for is not beginner, then it will actually go to the otherwise. As part of the otherwise, it will again check for intermediate. If the value in suitable for is intermediate, then 1 will be assigned. If not, 2 will be assigned. So the logic will actually assign 0 for beginner, 1 for intermediate. For all others, 2 will be assigned, which means for advanced, 2 will be assigned. This is the one which is being passed with respect to order by. So as part of the order by, we are actually using this logic, which means the first level sorting will be based upon this custom logic, followed by sorting in descending order by number of ratings. Let's run this first. Now course_level is created. Once course_level is created, we should be able to run it. Now you should be able to review the output. You can see that all the beginner records came at the beginning. Within beginner, you can see that data is sorted in descending order by number of ratings. After beginner, you can see all intermediate courses. Within all intermediate courses, again data is sorted in descending order by number of ratings. Followed by advanced, again within advanced, all the courses are sorted in descending order by number of ratings. This is how you should be able to use when with otherwise to actually come up with the solution for our problem statement, which involves prioritized sorting. We can also solve this problem using SQL style syntax. If you would like to use SQL style syntax as part of your Dataframe APIs, one of the ways to actually pass SQL style syntax is by using expr function. Expr function is available as part of pyspark.sql.functions. This will take care of importing expr. As part of the expr, you can have case and when statement in the similar manner as per SQL. If you are familiar with SQL, SQL supports case and when. Using case and when, we should be able to replicate the logic which we have seen earlier. In this case, you can see when suitable for equal to beginner, we are saying then 0. If suitable for equal to intermediate, then 1, otherwise 2, which means for advanced 2 will be assigned. In the similar manner of when and otherwise, depending upon the value in column suitable for each and every suitable for value, it will be assigning 0, 1 or 2. Now we should be able to pass course level which have this logic using expr to pass as part of sort or order by like this, and then we should be able to specify the other column in descending order. Then you should be able to see the data as per the expectations. So using expr also, we should be able to come up with the solution where prioritized sorting is implemented using custom logic on one of the columns. It is very, very important with respect to the projects. With respect to the certification exam, it is highly unlikely you will be seeing any questions around this, but there is no harm in being prepared for this, because in general, prioritized sorting is very, very important.